Hi, it's product review time. We've got the Korad KA3005P 30 volt 5 amp programmable power supply, and this one's rather remarkable in that it's probably one of the cheapest programmable supplies on the market. I got this from Triosmartcal here in Sydney, and they have it for 199 Australian dollars. That's for 150 watt linear. You say in switch mode, this is a linear programmable USB serial power supply. Brilliant. You can pick it up cheap at US dollars, but beware, it is if you're in Australia, don't buy the US one. It's non-switchable, 240 volts only, as we'll go into. But yeah, these things are quite remarkable, and I've already done a teardown of it, so check it out here. Click the link. Now, the first thing you notice about it is that it's this nice, compact, slimline, vertical format, so it doesn't take up much footprint on your bench itself or up on your rack space above your instrument rack. So you can conceivably put, you know, a couple of these side by side there, cheap enough to buy a few anyway, and have a very versatile supply. So it's actually, I rather like this format for power supplies. It just seems to work, and it's quite a sturdy instrument. And if we take a look at the back here, we've got USB and serial, both optically isolated from the input. The USB is, as you saw in the teardown, is electrically connected directly to mains earth, but apart from that, it is optically isolated from the output. Brilliant. One large cooling fan on the back. IEC input, as I said, 220 volts only. The US versions would presumably be 110 volt only, so if you're buying internationally, just beware you get the right version. Trap for young players. And the thing's pretty hefty as well due to the large linear transformer in there, because this is a linear supply, not a switch mode. Transformer is centered in the middle there, so the weight distribution is pretty even. It's a fairly sturdy supply though, in terms of you know, the cases, reasonable thickness, reasonable quality, and yeah, I don't mind the build quality at all, certainly for the price. And if we power it up here, we've got independent voltage and current readouts, as you'd expect on any good lab supply, plus a whole bunch of indicators. We've got over voltage protection, over current protection, which are separate modes you can select, constant current mode, constant voltage mode, and whether or not the output is off or on, because it's got a soft output switch, and up to 5 different memory recalls. Although, curiously, there are only 4 memory recall buttons here, but there are 5 LEDs. Go figure. And you can tell it's sort of, you know, low cost, a bit slapped together. The faceplate they've put on here doesn't quite line up with the 7-segment display in there, so it's all a bit out and it's all a bit wonky. But you know, I mean, for the price, you're not going to complain about little stuff like that. But it does have, it says it's a 30 volt 5 amp supply, but the display and the adjustment range is certainly capable of going up to 31 volts maximum and 5.1 amps maximum. So it's got one optical rotary encoder knob, which feels just like any other, you know, cheap optical rotary encoder, but it's certainly adequate for the task. It's got, you know, reasonably good purchase. It does have the little finger in there, hold in there, so that you can wind it around and around. Pretty nice. And the buttons are, of course, the soft PCB mount buttons, as you're familiar with. And my one's a bit sticky on the M2 button. You've got to push it a bit harder than the others, but you know, I mean, what do you want for the price? It's got the 4 memory buttons here. They store constant voltage and constant current as well for each one. So if you wanted, say, 3.3 volts at 1 amp, you could do that and store it in there. And you can recall them with a single press. And the lock button allows you to lock and unlock the keypad. So if you've got your supply set to 3.3 volts and you don't want to blow up your, you know, expensive $10,000 board, you put the lock on, and doesn't matter what you do, what you press, the recall buttons or the adjustment or whatever, it won't affect the output. It locks out the keyboard. Excellent. It's got over current protection as well, over voltage protection. Excellent. And an output on-off button, which will try out, and current and voltage adjustments, which adjusts the digit. And output, it's only a single output power supply, of course. The binding posts are reasonable quality. I don't mind them at all. They do come right off. They've got the banana plug in there. They've got the hole for the wire as well. So let's check those out. And it's got the separate earth terminal as well. And they are a standard pitch, industry standard pitch. So you can plug on your BNC connector or whatever. Brilliant. And it does have a real clunky on-off power switch, which actually switches the mains primary. So it's got pretty much every feature you would want in a single output lab supply, and but it's also programmable. It's also available cheaper in a non-programmable version, but I don't think you're paying that much more for the programmable one with the USB and serial, and we'll try that out later. So let's have a look at some of the functions here. It's got the on-off switch, and what I really like here, okay, the output, right, it's telling us the output is on, so voltage is switched onto the output terminals, and so it switches between displaying the output current, and when you turn it off, it switches to the adjustable output current. Great, that's exactly what it should do. There are some supplies which don't do that, and it's a pain in the butt, and you've got to short the output to adjust the current and things like that. Pain in the ass. This one does it very nicely, and to adjust the voltage and the current, never thought you'd ask, you hit voltage and current, and it jumps between the two displays and flashes the digit there. So let's adjust the voltage, and we can use the left and the right buttons here to select the digit. Oh, what happened there? To select the digit that we want to adjust. And no, it doesn't just adjust that digit. So if we go in here, say 1 volt, we can adjust it like that, and it goes all the way down and operates on that 1 volt. So we can go over to here, 100 millivolt resolution, great, and we can go over here, 10 millivolt resolution. Excellent. I don't notice any missing or doubled up jumps there on the optical rotary encoder. Seems to do the business. But like if you leave it there, say 6 there, for example, and you jump over, it doesn't round it off. It actually just bumps up that digit like that, and it does exactly the same thing for the current. So you go down here and you can adjust the current all the way down to 1 millivolt resolution like that. So the resolution, unfortunately on the voltage scale, I would have liked to have seen it scale up there and go 9 point XXX volts, so we got 1 millivolt resolution, but we don't. We get a fixed 10 millivolt resolution. Bit of a bummer there. The amps, they get away with it because you don't need better than 1 millivolt resolution on the amps really, so that's not that big of a deal. But yeah, it goes all the way down to 0 volts, and as you can see, it automatically switched out of that mode there. If we press it, enter it, it'll automatically jump back out if you don't touch the optical rotary encoder in like 5 or 10 seconds. So setting and adjusting the voltage and current works quite well and quite intuitive. I like it. As for programming the constant memories here, we can just, if we want to recall them, for example, I don't know it's programmed in here yet. Let's have a look. We've got this horrible buzzing sound. Not sure if you can hear that. Here we go. I'll put the mic up close to it and see if you can hear this. It's a pretty horrible sort of sound. I don't really like the buzzer at all. I think they've really goofed that one up, I think. But anyway, it's a bit sick sounding and just doesn't instill a lot of confidence. But to recall the program memories here, it looks like it's automatically programmed. No, we must have pressed M1 before. Anyway, let's press, say, M3, 23.2 volts at 4.37 amps. Well, let's play around with that. Let's say we want 12.2 volts and we want 1.07 amps. Well, we want to program that into M3. You just press M3, hold it down, and that should program that in there. So there it is, 12.2 and 1.07 works a treat. And of course you can see which mode you currently recalled here. So I don't know why they've got M5 here. I was playing around with one at Triosmartcal and we sort of managed kinda to get into M5, but I don't know, maybe you can program it via the serial port or or something like that, but there's only 4 matching buttons on the front panel, but that's more than enough really. And of course, if you're here working on your board and somebody comes along and accidentally, you can't accidentally, adjust it with the knob, which I really like. If you accidentally brush it and, it doesn't adjust at all without the keypad lock on there. But certainly, if you come along and accidentally press that, oops, you could fry your board. So that's bad. So that's why you want to put the lock on. So you just hold down the lock button. And once again, a pretty sickly sounding beep there. But now you can't do anything. Can't do a thing. It totally locks out the keyboard. And wonder if it locks out the serial port. Don't know. But you just hold it again. And bang, we're back to playing around with it to our heart's content. Now, it appears to have a temperature controlled fan in it. Of course, I've got no load on here at the moment, but it's enough to be a little bit annoying. Mine's got it seems to have a slight rattle to it or something like that. I don't know if that's normal or not, but anyway, just bear that in mind. These certainly aren't silent. It doesn't switch off the fan with no load. And I've had this switched on for about 10 minutes, drawing no load at all, and that is reasonably warm under there. I'd estimate 35, maybe 40 degrees Celsius already on the base plate. And if you really don't like that sickly beep sound, you can actually hold it and for a couple of seconds and it will switch off the beep sound. Excellent. I like it. That's the way it should be. Now I'm having a read of the manual here, which is all in English, by the way, and it's pretty darn basic stuff, but it has nothing on the operation of the overcurrent protection and the overvoltage protection, or at least start setting it, whether or not it's even settable at all. And I haven't really been able to figure out how it actually works. Now for some testing, we've got the right tool for the job, the BK Precision 8500 300 watt programmable DC electronic load, and this thing is just as accurate as my Fluke 87 multimeter, so the voltage and current readouts are super accurate, so there's no need to even hook up a Fluke meter to check the accuracy on this thing. This thing can do it no troubles at all. Now I've just got that connected directly into the load, of course, straight over, so we can check out its constant current performance and its turn on its load transient performance and all sorts of stuff like that. And then I've got a banana plug to BNC adapter going into my Agilent 3000. Okay, let's check the display accuracy, voltage and current for different constant power levels. So I've got it set to constant power 1 watt, little tiny 1 watt load at the moment. So we're in constant wattage mode. You'll see a little CW there. So we'll be drawing a constant 1 watt. My current limit's right up and 1 volt. So let's switch the output on, and you should hear the fan switch on, by the way. Let's go. Wham, you can really hear that. It's so, when it's drawing 1 amp on the output, 1 volt, of course, 1 watt, then let's have a look at the correlation of the displays. Pretty close to spot on. Beautiful. It's almost practically least significant digit stuff. I got no problems with that at all. Let's increase the voltage, and you can see the fan just dropped a bit there, so it took some time. So 5 volts is spot on, and yeah, the displays, I've got no issue with this at all. 10 volts, we just heard the relay click in then. I'm not sure if you heard that, but it's pretty close. A little bit out on the current display, but you're only talking about a couple of, a few milliamps. I mean, it's quoted, that's well within inside its quoted accuracy, by the way. Anyway, let's change this power watting. Let's go up to something a bit more substantial. Let's go up to 10 watts. Ta-da! Oh, I love this. Oh, this constant current load. Oh, it's a thing of beauty. It really is. Got to have it exact, just because we can. So drawing a constant power of 10 watts. Okay, now we're talking. And here we go, 323. Yep, it's all pretty close to spot on. I like it. Let's drop down to another relay setting, 555. Timer category, and we're only 5 millivolts out there. It's not much. It's not bad at all. So that fan just really kicked in again. That fan is really quite loud. I'm not sure if you can hear it, but wow. Yeah, you wouldn't want that running all the time, that's for sure. It is quite loud. All right, let's try and test the maximum load of this thing. Let's set it for constant current mode, 5 amps. There it is, and we'll switch it on. Full voltage out here. We've got 31 volts, and the current limit is set to the maximum there. So let's switch it on and see if it can deliver that. And, well, it certainly seems like it's able to. That's a full 150 watts. And if you're curious to see what's happening at a constant 150 watts on the output, well, I've got it AC coupled, bandwidth limited. We can switch that on, but we'll have the bandwidth limit on. And I've got it in high resolution mode as well. There's regular mode, of course, but let's put it in high res mode, and that is working a treat. That's 10 millivolts per division. No dramas whatsoever. No, I think there's some funny business happening here. Constant power, switch it on, and I'm only getting 0.2 volts at 5 amps, and there it is, 0.2, which is really quite strange. Let me try that again. So I'm not sure what's going on here. Let's switch my load off. Bang, we're back to 30 volts output now, 31 volts, and let's set that to, instead of constant power, let's set that to constant current. So let's set that to 5 amps. Bang, and we'll adjust our voltage to 30 volts at 5 amps constant current. Let's give that a try. So we're in constant current mode. Okay, we're drawing our 150 watts. Well, let's try the load switch on with 150 watts in constant current mode now on my electronic load. Let's give it a go. Whey, look at that. Woohoo! What on earth is that? Is that the power supply, or is that my load, or is it a combination of both? Playing funny business. Let's try it again. One more time. Wow. Third time. And that's with a constant current load. So that is rather bizarre. I mean, you know, there's no overshoot there. You don't have to worry about that. But let's take it down to 15 volts and see what happens. All right, 5 amp constant current load, 15 volts output. Switch on, and bang, there's a nice little kink in there. Look at that, boing. But it does not overshoot. Let's do it again. No, still doesn't overshoot. So the ramp up performance, that might be where it's switching. I mean, it shouldn't switch a tap on the transformer because it should know that it's already in 15 volts. So now I've got it set to 50 watts constant current load at 15 volts output, and that's our switch on performance. Nice and, you know, relatively clean, no overshoot there, a little bit of a step thing there. So let's try that again, but watch this. Sometimes I'll zoom out and let's press the button here, our load on off button. So let's capture that again. But look at that. It's jumped up and then it's ramped back down to 0.2 volts. What's going on here? There's definitely some funny business going on here. I've got 4 amps constant current set with a 50 watt constant load, so we should expect at 15 volts, you know, 3.3 amps or so. And we switch it on, and sure enough, that's what we get. But we do it a few times, and we'll eventually get to a point where this voltage will drop down. I'm not sure if it's like some sort of over voltage protection mechanism kicking in. It shouldn't, because we're not doing anything. But I'm having a hard time. There we go. Bang. got it. What's going on? And if we switch it off, of course, it will switch back on with the load off. But it actually retains the settings we've got storing them in the E-squared prom in there, which is excellent. But it doesn't switch a load on, so that's a good thing. So you've got to manually switch it on with the load button. Bang. All right, let's check some switch on performance. Now what I've got is 3.3 volt typical power supply voltage, 5 amp constant current limit, but I've set my load to constant current at only 4 amps, so it'll be booting into constant voltage mode and not into constant current mode. So let's capture it on the scope here and see what happens. Switch on. Bang. Transient. That's not that great. Look at the overshoot there. There's a little bit of step there, then it ramps up pretty linearly, but it goes up to 4 volts. That's not great at all. I don't like that overshoot. That's pretty terrible. Make sure that wasn't a fluke. Nope. Totally repeatable performance. Hey, this thing's no good at all for powering. Well, I wouldn't like to power a large 3.3 volt board, because that thing's going to overshoot to 4 volts. Nasty. Let's try the same thing again, but this time I've changed my constant current load to an amp. So, bang. Hey, there we go. It's a different performance again, but it really hasn't essentially overshot this time, but it's got this nasty little down. The switch on performance isn't great there at all. I'm not very happy with that. Let's do that again. Totally repeatable. It looks like same performance again at 5 volts at 4 amps. I dropped my current down to 1 amp, and let's try it again. Bang, that's at 1 amp. Switch on performance for 1 amp load. But check this out, 20 volts now, 1 amp. Bang, the switch on performance for 1 amp is quite, there we go, that's not bad. And if I just switch my load to constant power, I've got 10 watts constant power, so it's giving us 10 volts at 1 amp, 10 watts. So this is the transient switch on performance for 10 watts constant power. Let's go into 10 volts constant current mode, and let's do it again. And that's our switch on performance for 1 amp constant current mode, again 10 watts. And what if we've got no load at all? Well, let's give that a try. Here we go. Bang, and that's with no load. Zip. So, but there's no overshoot, no problems at all, but let's wind this down to, and let's try no load at 3 volts. Bang, there we go. No overshoot, a few little step responses there. And let's see what happens if I switch my constant current load on and see how quickly this current display ramps on and stabilizes. It pretty much jumps in there. It gives you a slightly lower reading. It jumps pretty much straight to it. So there you go. It's a little bit out, but we're only talking like 20 milliamps out at the full 5 volts. That's under 1%. No problems at all. Uh-oh, folks, something's gone horribly wrong. Something's gone horribly wrong. It's showing 36 volts on the output here, but its output's actually 42.3 volts. I was mucking around with the constant resistance mode on my power supply, and I had it set to 1 ohm. I got it set to 1 ohm there, constant resistance, and I was mucking around with that, and 6.5 amps. We're all over the shop here, so it's not going constant so much for the constant current mode. Well, something's gone horribly wrong here. Ugh. I don't like this at all. And it's stuck on 36 volts output. I've managed to cause it to go into some ridiculous mode where it's gone massively. No, it's jumping all over the shop, and the display is not updating at all. That's constant resistance mode. We're getting 5-6 amps out of this thing, over current protection, over voltage protection on. Oh, it's going haywire. And really, there's no excuse for this. I mean, it's showing 12 volts at the moment. That's just nutso. And just will not switch that output on. But it's actually outputting 17.6 volts, even though it's only displaying 12. And here's my fluke here, and trust me, there it is. It's 17.6 volts. This load ain't lying. Well, I think the only way I'm going to be able to fix this is to actually repower the thing, reset it, which is crazy. Oh no, we've got our output. There we go. We've got our output. It's back again. But something's going on here, damn it. I don't like it at all. No, it's like, right, set it for 6 volts and it's 17.6 volts. What? You gotta be kidding me. Something's going wrong here. 12.2 volts. What do we get? And we're still getting 17.6 volts. Let's switch it off. And back on. 6 volts. Uh-oh, folks. I think we've killed it. I think we've killed the supply. Do you believe it? Wow. Output 17 points. Okay, so it's it's setting to 6 volts, and it's once you switch the output on, of course, it goes to what you're actually displaying, and it's now displaying correctly the output voltage, but yeah, it's crazy. It's set to 6 volts. Fail. Gotta be kidding me. Unbelievable. Woo. And now it's gone off the deep end. We're talking 56.5 volts. It's like if I switch that load on, if I go back to, say, constant current, let's set it to a very basic 1 amp here, and we've gone into constant current mode. It's saying it's outputting 50 volts at 1 amp. It's peaked here. It's gone max, and that is a real voltage. Look, let me probe this. This load ain't lying. There is 50 volts on that output. That is nuts. Well, it's more than gone off the deep end. I've got the output switched off, and it's still giving me 14 volts at 1 amp output. The output is switched off, damn it. Look, it doesn't even switch the output voltage off anymore. You've got to be kidding me. It switches the mode, but it doesn't. It's continuous output. Well, what can I say? That's the end of the bloody review. I'm not even going to bother going any further. I've killed it. The EEVblog review curse strikes again. Now, this is unbelievable. The fact that I've done something to it. I'm going to have to open it up, have a look at it, but it's completely died. And not just like not giving any output, it's giving output over and above what you set it, even when you turn the thing off. It's ridiculous. And it doesn't matter what I do with this load here. I can short this thing out until the cows come home. A good power supply, you shouldn't be able to kill it. It's ridiculous. God, not if it's just going to die when I'm just playing around with an electronic load like this. It should be able to survive dead shorts on the output, because that's what all the current limiting and everything's for. Unbelievable. Loser. I'll keep you up to date with what happens with this thing. Maybe we'll try and investigate it somehow, but hey, sorry Charles, I killed your power supply. You want it back?